Hello students and welcome back to my channel. This is the toxicology series of videos, and today we're going to continue by starting a new section, the nutritional toxicology. So expect to learn in this video the introduction to the toxins we can find in food, as well as the gastrointestinal toxicity together with the food allergies. Hi, I'm Tommy. I'm a human nutrition student and researcher at the university. What I do in this type of videos is to synthesize my classes at the university so then I can explain and teach you the best and most valuable information you need to know. So let's begin by taking a look at the nutritional toxicology. So the nutritional toxicology assesses the presence of toxic and anti-nutritional factors in food, and they do this to ensure that they are harmless or very low risk. We can find natural toxins in food, such as chemical agents, that are in higher than normal concentrations, so they are normally present. And this can create occasional intoxications. Some examples are the cyanogenic glycosides in the cassava and almonds, the furocoumarins in the parsnips, the lectins in the dried beans, the mycotoxins in the molds, the aquatic biotoxins in the algae, the solanins in the solanaceae family, the mucimol and muscarine in wild mushrooms, and the pyrrolizidine alkaloids when weeds contaminate the crops. Then we also have the accidental toxins. These are correlated with the environmental causes. And there are also intentional toxins due to misuse. This is, for example, when not applying the correct amount of pesticides in crops. And you have to know that there are some food hazards, some factors to take in account for the toxicity. These are biological, such as microorganisms, chemicals, toxic substances, or even physical, such as the presence of radiation or pieces of glass. And a contaminated food is a food that contains one of these hazard factors. And from that we can differentiate, for example, the microorganism alteration or not of the food, and we differentiate intoxications from toxin infections. The intoxications is the presence of a toxin, and the toxin infection is the presence of the microorganism that will then produce the toxin. And on the other hand, we have chemical, which can be natural, environmental, due to contaminants, or even from additives. We can also have toxins that are generated during food processing. This is, for example, the acrylamide due to the Maillard reaction, the persistent organic pollutants, and we will have a video about that in more detail, the free MCPD and the glycidiol, the polycyclic aromatic hydrocarbons, and I'm going to do a video about that as well, the furan and the melamine, which has to do with the materials that are in contact with the food. So in order to ensure that the food we eat is harmless, there are some agencies that take that responsibility. For example, the World Health Organization, which has the food safety policy, the white paper, and the From Farm to Fork policy. This is to ensure safety in all areas of food processing. We also have the ASAN and the EFSA with the control system RASF to ensure food safety, together with FAO as well. And they do risk characterization, management, and communication. Remember that from the first videos of this subject. And there is the concept of One Health, because the environmental health is correlated with animal health and human health as well. And to make sure that food safety applies, we have to follow a balanced and healthy diet. And food safety is a right and a duty as well. So something we have to request, but we have to contribute as well. Moving on, we have the toxicology of the gastrointestinal tract. And the mechanisms of intestinal toxicity is basically that this is a target organ. It's one of the main ways of exposures to toxins. If you ingest something, you're going to be exposed to those toxins. The intestinal toxicity mechanisms are several, such as the disruption of the intestinal epithelium, causing necrosis of it due to ischemia, low flow, low nutrition, and death of the tissue. And it leads to the suppression of the mitotic activity. Then there is also the interference with secretion, muscarinic agents, parasympathetic agents. For example, osmotic cathartics will create a diarrhea, and the adenylate cyclase activation is correlated with the cholera. Then there is an interference with mobility. There are direct irritants that will create a higher propulsion due to the irritation. The cholinergic agents that stimulate the acetylcholine and the contraction of the intestine, so it will again promote the propulsion. And the cholinesterase inhibitors are also correlated with this interference with mobility. And then last we have the interference with nutrient absorption, which is one of the most important ones. For example, the aflatoxin, which is a mycotoxin, will interfere with the pancreatic lipase, impeding the lipid absorption, so lowering the absorption of vitamins. Fat-soluble vitamins are very, very low. This has to do with cholestatic agents. There is a low bile, and if there is low bile, there is low absorption of fat-soluble vitamins, ADEK. The susceptibility of organs toxicity depends on blood flow, the presence of specific enzymes or biochemical pathways, the organ function and position, the specialization and vulnerability, the repair capacity, the metabolism balance, the presence of specific intake methods, and the compound binding to macromolecules. And the toxicity based on location, we have local toxins, which can be corrosive, the acids, or caustic, the basic, the alkalines, or systemic toxins, which are correlated with damage innervation, vascularization, and secretory glands. Talking about vascularization in more detail, there is a microcirculation alteration and an affection to the hepatic portal circulation. Due to this, we can find neoplasms and angiosarcomas, which are tumors that can derive from either synthetic substances, toxins, or even natural toxins, such as the pyrrolizidine alkaloids, for example. And the granulomatous lesions are also related with porphyria. Then taking a look at the liver toxicity in more detail, we can say that hepatotoxicity is very bad because the liver is the metabolization center of the organism. And an indicator of this is that it contains the glucose 6 hepatic phosphatase, which is able to release glucose to the bloodstream and deliver it to the whole body. So when there is a lesion, there is a decreased synthesis of plasma proteins, which is very important, and unaltered cholesterol, triglycerides, and free fatty acids. So dyslipidemia can occur when there is a liver lesion. The characteristics are increased liver size and weight, pathological proliferation of smooth plasma reticulum as well. And we encounter the cytotoxic liver with necrosis and the cholestatic with the bilirubin accumulation. Let's take a look at the cytotoxic first. We can differentiate here with chronic toxicity leading to cirrhosis and acute toxicity, which is indeed liver damage. The chronic one creates chronic active hepatitis, together with a necrosis of the portal circulation and inflammation. It has a steatosis, which means a shrink of the liver, of the hepatocytes. It creates a fatty liver with fibrosis and cirrhosis. On a microvesicular level, this is due to phosphorus and tetracyclines. And on a macrovesicular level, is due to alcohol and methanol. Then it also has vascular liver lesions, tumors, and granulomatous lesions as well, the chronic one. On the other hand, the acute one, it has a parenchymal degradation, a swollen liver, bulging mitochondria, and fine eosinophilic granulation, as well as hydropic degeneration, which is an hepatocellular damage where we have a lot of water, a lot of swelling, and a water uptake indeed. And there can also be a liver necrosis, which is focal, zonal, massive, time-dependent, and if short, is more lethal. So to recap, a fibrosis, which is an increase in collagen, is onset of necrosis. The cirrhosis is progressive and irreversible, and it's basically a fibrosis together with an abnormal structure. And then a vitamin A or even aflatoxin intoxication can lead to this cytotoxic liver. On the other hand, the cholestatic has a bilirubin accumulation, which indeed will create the jaundice because there is less bile available. And we can find this when the whites of the eyes turn yellow and there is a fat-soluble vitamin malnutrition. And jaundice is correlated with steroids and contraceptives. So the evaluation of hepatotoxicity is done with subclinical responses: hypersensitive, adaptive tolerance, and hypothesis. These are all things that we have to take in account. But the main things are the enzymes. We measure the enzymes because they are indicators of injury. And the blood tests, we have the ALT and AST. And we also have the alkaline phosphatase, the bilirubin, as we talked about here in the cholestatic lesion, and the glutamyl transpeptase. These are all enzymes that will indicate a liver injury. And then last but not least, we have the gut microbiota. The composition, well, it differs a lot. It's not the same the bacteria we have in the mouth as the one we have in the intestine. And the mouth bacteria is related to some cancer development if it's a dysbiosis. And the microbiota evolves with the time. As we age, it changes, and also with our habits. And we have to take into account the prebiotics and probiotics definitions. Prebiotics are the ingredients that are needed for the microbiota to grow, whereas the probiotics are the microorganisms that contribute to our microbiota. And we do not have to combine antibiotics with probiotics. It's nonsense. And we have to be aware of the saliva, as it may cause sepsis in some cases. Okay, so now it's time to take a look at allergies. Here we have the epidemiology, the food allergy perception. 1/3 of the population has a food allergy perception. But actually, the food allergies is only 2% of the general population, 7.5% in children and 10% in atopic individuals. So as you can see, it's very low. But why is that? There are geographical differences. There is an importance of differentiating between children and adults. And the first dated anaphylaxis was in 1905. The risk factors are the lack of food identification, mainly. And the patient-dependent factors are the medical history of an individual, the idiosyncrasies, the asthma, and the medication he or she is taking. And of course, there are individual differences, the idiosyncrasies. The classification, we have toxic adverse reactions and non-toxic adverse reactions. The toxic ones are anaphylactoid type. They do not cause with anaphylaxis, but they have a similar symptomatology. This is due to mushrooms, for example, and we have a video talking about that, goitrogens, and the overconsumption of some toxins, such as one of these, natural, accidental, intentional, or generated by food processing. On the other hand, the non-toxic adverse reactions are differentiated between hypersensitivity, which is the allergy, and the food intolerance. The allergy must be in sensitive individuals to a certain food, a food that the majority of the population tolerate, and it has an IgE immune reaction, which can lead to an anaphylactic shock. If it doesn't have an IgE, it's not an allergy. And food intolerances are non-immune system based, so no IgE. And it's an intolerance to an additive or non-immune food. And the causes can be metabolic, such as the lack of enzymes, for example, in the lactose intolerance, pharmacological, due to certain compounds, or indeterminate, maybe a combination of both. This is a genuine food intolerance, not a psychological aversion. That's why a majority of people think they are allergic to something, but they are not really. And the most common ones are milk and eggs. And the food intolerance inducing factors are non-allergic histamine release, metabolic deficiencies such as milk intolerance, the celiac disease. The celiac disease can be either allergic or non-allergic, pharmacological effects, xanthine bases, and the food intolerance of unknown origin, which can be correlated to additives and yeast. And the food allergy is associated with protein, and it triggers the immune response, the immune system, with IgE. The food allergen, the first is the contact, the second is the immune response, and the third is the symptoms. These are the steps of the food allergy. And associated problems are the fear of sudden intoxication and especially cross-contamination. It's very important. The prophylaxis is to take a look at family history, testing for allergy, of course, avoidance of dangerous foods, read the labeling, take antihistamines, steroids, and have a medical alert bracelet. And the most common allergens are cow's milk, the food additives, very interesting, eggs, fish, shellfish, fruit, and vegetables, interesting as well, legumes, nuts, and grapes. Okay, this is it for this video. I hope you understood everything I said. If you didn't, there is a comment section down below. Don't forget to like, subscribe, and turn on the notifications so you get notified every time I upload a new video. If you find value in this, please share it to your friends and family to spread this knowledge to them as well. Thank you so much for watching, and I will see you in the next one, in which we're going to talk about marine biotoxins and hunting products. So I will see you there. Hope you enjoyed. Ciao!